All right, let's move on to number 17, where we're going to solve the same quadratic equation 4 different ways by factoring, completing the square, quadratic formula, and then also to graph it and see where the x-intercepts are. So let's do the factoring first. Let's see here. So we need to find what two values, right, multiply to this product, 8x squared, and add to the b value. Okay, and after just a little bit of trial and error, you can find out that that'd be 4x and 2x. 4 times 2 gives us the 8. 4 plus 2 gives us the 6. So we'll have x squared, and instead of the 6x, I'm going to put the 4x plus 2x. This is called factor by grouping. Okay. And just find the common term with the first two, and then the common term with the second two, and that will give us our groups. So common term with these two is they both have an x, right? And common term with the second two is they both have a 2, positive 2. And the requirement for this method is that both of these parentheses need to be the same. So when I ask myself x times what equals x squared, I get x. X times what equals 4x, I get positive 4. This should also come out to x plus 4. So 2 times what gives us 2x? X, that's good, that matches. And 2 times what gives us 8? That's positive 4. So both of these match the x plus 4s. So the two factors will be, one of them will be x plus 4, and the other will be x plus 2. So that is the factored form of this quadratic equation. What we started with is called the standard form. When it's in this format, when we have the a, b, and c. This is the factored form. The factored form is nice because it gives us the x-intercepts. The standard form up here is nice because it gives us the y-intercept, 8. So they both have their benefits here. So just to finish this up, because it says to solve, not just factor, but solve it. So we need to find out what our two x values are. Subtract 4 on both sides, you'll have negative 4. And subtract 2 on both sides, you have negative 2. So x equals negative 4 and negative 2. There we go. So since I'm going to solve the same exact quadratic 3 other methods, I should get the same exact answer. So if you're doing these and you're getting different answers, you know something's up. So let's look at, how about the, right down here, let's do the quadratic formula next. Here we go. And we'll use 1 for A, 6 is B, and 8 is C. This only works when we're equal to 0, so if we had some other value on the right-hand side, we'd add or subtract that first, but we're good to go on this one. Formula is negative b plus or minus square root of b again squared minus 4 times a times c all over 2 times a once again. So we have negative 6 plus or minus square root of 6 squared minus 4 times a times c all divided by 2 times 1. All right, so order of operations, just need to be careful with negatives. we'll have negative 6 plus or minus 36. And we have 4 times 1 times 8, so that's minus 32. All divided by 2. A little more simplifying. All right, so I got it down to fully simplified. And remember that this indicates two answers. One of them is negative 6 plus 2 divided by 2. And the other indicates that it's negative 6 minus 2 over 2. If we just simplify each one of these, we'll have, see, negative 4 divided by 2, which is negative 2. And over here, we'll have negative 8 divided by 2, which is negative 4. So just as predicted, it should match what we got with the other method. Same problem, different method has the same answers. So x equals negative 2 and negative 4. So let's look at two more methods. One with completing the square. So start off completing the square by moving the c value to the other side, because 8 is not the proper number for this perfect square. All right. Our goal is to write it as a perfect square, meaning it's going to be the same binomial twice, right? And the way we do this is we take half of b, which is 6 divided by 2 is 3. And then 3 squared is 9. I need to add that to both sides. And then 9 minus 8 gives us 1. So that's the process of completing the square. So x plus 3 times x plus 3 will give us this trinomial right here. And the reason we want it in this format is because we can solve it really easily by square rooting both sides. So we'll have x plus 3 equals plus or minus, right, 1. And then just like before, we'll have two answers. X plus 3 equals negative 1, and x plus 3 equals positive 1. Just solve these individually by subtracting 3 on both sides. So we'll have x equals to negative 4. That's good. And x equals to negative 2. So for a third time, they all match. There we go. Lastly is just to graph it. So there's lots of ways to start off by graphing. We can use some of the information we've already found out, but if we just go ahead and plug in values, we could figure out what the graph is that way as well. So first off, remember that this last constant term, constant means there's no variables on it, okay, that's the y-intercept. So I already know that this number on the end is always going to be 0, comma, and whatever that number is, 8. So that's the first value I can get right away without any work. So I'm going to set up a table of values to graph this. Now we're going to kind of ignore that we already solved this 3 other ways, and we already know that the x-intercepts are negative 2 and negative 4. So we already kind of know this is going to happen right here. But let's say we didn't, and you're just being asked just to graph this. We know we have 1 point, but in order to really graph this properly, we need to know where the center or the vertex of the graph is right away. So what you want to do to find the vertex is take a little piece of this quadratic formula. So right here, the part that's not in the square root, this negative b over 2a, actually tells us where the vertex is. This other value, the discriminant here, tells us how far apart are the two roots from the vertex. So we're going to have the vertex plus a value and then the vertex minus a value. So I'm just going to pretend I don't know any of this and use just this highlighted yellow part of the formula, negative b over 2a, to tell me where the vertex is. So once again, a is 1, b is 6. And that part of the quadratic formula is just negative b over 2a, ignoring the rest of it. So we'll have negative 6 over 2 times 1, which equals negative 3. So this tells me for the x value, use negative 3 for the center of the graph and also the center of the table. And if I want to find the y value, this is where you plug negative 3 back into your original function. You find f of negative 3. So you find f of negative 3, and that'll give us this value. So we'll have negative 3 squared plus 6 times negative 3 plus 8. So that's 9 minus 18 plus 8, which gives us, looks like, negative 1. So my vertex is at negative 3 comma negative 1. So that's 1, 2, 3, down 1. And then the process would be to choose the next number that's smaller and the next number that's bigger and find out what they are when you evaluate them in the function. All right, so if we went through and did this process several more times, so find f of negative 2, that's going to be negative 2 squared plus 6 times negative 2 and plus 8. So we'll have 4 minus 12 plus 8. So you can see that this equals 0. And that's how you know graphically that this is one of the answers, the fact that it equals 0. So negative 4 comma 0. And we don't need to do the, oh sorry, we found out that negative 2 is the answer. There we go, got ahead of myself. So we know negative 2 comma 0 is the answer, and we don't need to do negative 4 because by design, these will be the same answer because it's symmetric. So I really only need to do one of them. And then repeat the process one more time. Let's say negative 1 and negative 5. Find out what f of negative 1 equals. So this is graphing just by plugging in points. It's the slowest of the methods, but it also works when nothing else does. So if you're not sure, this is the fallback if you have the time to do it. Okay, so I plug in all the values. 1 minus 6 plus 8 will give me 3. Okay, of course I'll get 3 for both. So negative 1 comma 3, and we'll have negative 5 comma 3 as well. And we already have the y-intercept here. We already know what 0 is. It comes out to 8. So I also have the answer for negative 6. The next x value in that direction is also going to be 8. So graphically, it's just symmetric. So that's how we can graph this. By using all the information we gathered here. There we go. Okay, so There's our graph. Now there are many other ways of graphing. You can use some of the other information that we gathered here. Like for instance here we can see if we have x plus 3 squared equals 1, well that can also give you the vertex of -3 comma -1, right? It's just the opposite signs here. So if you use more information here, there might be a faster way. This is just one way to solve by graphing. All right, let's look at number 18. All right, so if we have roots that are plus or minus 5, all right, so that means if we have done the process and we know that one answer equals 5, another answer equals -5, how can we find the equation in standard form? All right, so what we'll do is we need to come up with two factors, right? One that equals 5, one that equals -5, one that's set equal to 0. So for here, to get an answer of positive 5, I would need to solve x minus 5 equals 0, right? So this is the equation that you would solve in order to get positive 5 as an answer, because you would add 5 to both sides, right? And this would work for any values at all. And same thing here, we need an answer of -5, so in the same way, this would be x plus 5, because x plus 5 equals 0, if you solve, would give you an answer of -5. Right, so we're just doing the same process we normally do, but in reverse. Now they want it in standard form. This is factored form, which basically means you need to multiply this all together. So we'll have x squared plus 5x minus 5x, and then minus 25. Simplify this a little bit. You can see that we have a plus 5x and a minus 5x, so those cancel, and we're left with x squared and -25. And there you go. There is our function that has 5 and -5 as the roots. Let's do the same thing, but with imaginary roots. So instead of 5 and -5, we have 3i and -3i. So it actually works exactly the same. You might be tempted to say, well, now what do I do because there's an I there? Don't do anything different than we did on 18. It's going to be the same exact process. So we'll have x minus 3i, right? And x plus 3i. So it works for any types of numbers, this format, this process here. If we know the roots, we can always work backwards to find the equation in this way. Multiply them together. X squared plus 3i x. But just like the last problem, these two middle terms end up equaling 0. Plus 3ix and minus 3ix. You might not like that it looks different and looks weird, but it doesn't matter that because they cancel out. Lastly, we have minus 9, right? -3 times 3 is -9, and I times I is I squared. That's the only part that's different. So here, we still have these canceling out. So we're left with x squared and minus 9i squared. Now we can simplify I squared. Recall that I equals the square root of -1. So I to the second power is root -1 times root -1, which equals just -1. So we have x squared now minus 9 times, instead of I squared, times -1. And just to simplify this one more time, -9 times -1 is +9. x squared plus 9 would be our function. All right, let's look at 20 down here, finding the standard form once again. So this is more of a visual of what we just did on number 18. Okay, number 18, they said, well, the two roots are this, write the standard form. Here, instead of saying these are the two roots, they give us a picture of the equation, graph of it, and you have to find out, well, the two roots here are 1 and 3. So this is basically the same thing as right above on number 18. You just have to pick the two roots out from the graph yourselves. Okay, so let's just do the same process, but as if they give you 1 and 3 instead of 5 and -5. So we'll go through this exact same process, multiply it together, end up with our function at the end. So we'll have f of x equals x minus 1 and x minus 3. Multiply it together. Of x squared minus 3x minus 1x and plus 3. Simplify this a little bit. This time the middles don't actually equal 0 and cancel, they just equal -4x. So we have x squared minus 4x plus 3. Now there's one more thing we need to watch for. You'll notice that this is opening down. So one thing we didn't look at before is that a value, the number in front, controls whether this opens up or down. And since this is opening down, I'm going to set that a value to -1. So let's distribute this. We'll have -x squared plus 4x and minus 3. And this will give us the two roots that we're trying to get, and also, because of the negative here, be opening down. And that will do it for this. Right, my f of x here. There we go. All right, let's go to number 21. All right, let's jump into conics now. Let's find the equation of the circle that has a center of -2, +1, there's our center, and then goes through the point -6, 0. So -2, 3, 4, 5, 6. So it needs to go through this point. Right. And the equation has two parts to it. It has the center part on the left usually. So we have x plus 2 plus y minus 1 squared, both squared. That's what makes it a circle, or how you can tell it's a circle just by looking at the equation. Both are squared and they're being added here. Then on the right-hand side, we have the radius. How far is it from the center to the outside points? So we need to know how far is it from here to here, right? And good way of doing this is using the Pythagorean theorem. So if we know from here to here is 1, 2, 3, 4, and from here to here is 1, we can use a Pythagorean theorem. A squared plus b squared is c squared. So this is going to be 16. Let's see here. 4 squared plus 1 squared equals what, right? So 16 plus 1, that's going to be 17. Equal to r squared, by the way. We could say c squared, but we're using r in this particular problem, so we're going to say 17. Now this is actually square root of 17, but in the equation you put r squared, so this is 17. So this kind of looks like a Pythagorean theorem. A squared, got something squared, plus something squared equals r squared, right? Basically Pythagorean theorem. So that would be our answer. On the graph, the actual distance is root 17, but in the equation, it's always the square of the actual distance. All right, good. Let's go ahead and go to 22, do some more conics. Okay, so let's find this equation of an ellipse that has a center of 4, -3, 4, -3, right down here, has a y major axis length of 7, so we're going to go up 7 and down 7. So down 7 will bring us to -10, up 7 will bring us up to 4. And then an x length of 4. So we're going to go left 4 and right 4. 1, 2, 3, 4. 1, 2, 3, 4. Right, so this will be the graph, something like this. There we go. Okay. And for the equation, first we'll start with the center, which is basically the same as the circle. So the center is at +4, so I'm actually going to make it x -4, right? And the y value is at -3, so I'm going to make this y +3. So opposite signs, just like the vertex or the center of a circle. Okay. What's different is that it's not going to be equal to the radius because we have a different value going this direction than we do going this direction. So we actually write it underneath that particular variable. So in the y direction, we're going 7 this direction and 7 this direction. So it's 7 squared underneath. So we'll have 49 underneath the y. And then the x, same thing. We go 4 this direction, 4 this direction. So that's 16 underneath the x, right? And for ellipses and hyperbolas, it's always going to be equal to +1. All right, so that's the ellipse. Let's look at a parabola. This time we have a vertex, -2, -3. So we have -2, left 2, down 3. So there's our vertex. Opens left, so we know it's going to be looking like this, right? LR is 4. All right, so opens left. Let's look at that first. So recall that the x squared parabola you learned a long time ago, right, always opened up and a negative opened down. So what we do to open left and right is make it y squared instead. So a positive y squared opens to the right and a negative y squared opens to the left. So we have a y squared that needs to have a negative coefficient. All right, so it's just about putting everything in the right place. So we'll have a format that looks something like this. Okay, the y will be squared and be on the right-hand side, which means the x will not be squared. And the LLR goes right in front of the non-squared parentheses. So this is the format you need to know. And again, this can change. This x and y can switch places. If it was opening up and down, the x and y would be in the opposite locations. So we have a, right here, vertex, right? And be careful, we want to match the x variable with the x coordinate. So it's x is -2. So I'm going to put the +2 right here, opposite signs once again. -3 will be +3 here. And the LLR, they say, is 4. So all we need to do, just take this out of here, is put in the 4. And to make it open to the left, though, remember to the left, I need this negative. So we're going to put that negative right here. This guarantees that it opens left by putting that negative there. And just to go ahead and graph it, since we have the equation now, opens left, and LR of 4, which means we're going to go left 1, and then the length here will be 4. So from here to here will be 4. Then I can use that just to sketch the parabola. There we go. So there is our sketch of a parabola. And here is the equation of that parabola. Okay, so let's start identifying these conic sections and get really good at knowing what the graph will look like before we even start graphing. Let's see here. All right. So 4 different types. You can compare them all and see, well, what is the same and what is different. Right? One of the giveaways of between these two is that one is positive and one is negative. So these are not all 4 of them, but just a parabola or a hyperbola, right? So we're just looking at those 2, not the circle, not the ellipse. And with a parabola, you're only going to have one of them squared. So you can see that's the giveaway that these are both parabolas. The y isn't squared here, the x isn't squared here. So these are both parabolas. With the hyperbolas, they're both squared, but one of the squares is going to be minus. So if you have a negative square, like we do on both of these, those are hyperbolas. So real fast, we'll know the general shape of all of these. So let's do the parabolas first. Like the last problem, we can see that it's y that's squared. So that's automatically an opens left, opens right, right? So that means this is out because we have a y squared. And this negative here, just like the last problem, let us know what direction, right or left. So the negative makes it open left, just like number 23. The next one here, I'll do the next parabola, is x squared. So we know it's going to be opening up or down, and the fact that it's positive, right? Positive, we don't have any negatives lurking around. Everything's positive, lets us know it opens up. Now for the hyperbolas. What you want to do is look at and see which part of the equation is positive. So if the y value is negative, it means that it's going to open in an x-ward direction. It's going to open right and left. Right? Remember, with a hyperbola, you have 2 choices, right? You have it with a graph. It can either open up and down, or it can open left and right. Right, so we're looking to find out which one. Is it up, down, or left, right? And again, since the x is positive here, it's going to be opening in x-ward direction, so it's going to be open left and right. Both of those. And down here, you can see it's the opposite. The x squared is negative, so the y is what's positive in this hyperbola equation, so it's going to open up and down. Right, because this is the positive part. Another way of looking at it is that when you have an hyperbola, it's whatever variable's first, because the second one is always the negative. So the first one will be the positive. The beginning of the equation will tell you what direction will this hyperbola open. So since it starts off with an x squared, I know that's going to be in left and right. This one starts off with the y squared. It's going to be an up and down. Okay, let's go and graph some conic sections now. So we need to use the idea that we have to have the type of conic section first before we can go and graph it. So like we just did, we need to be able to identify what it is we're graphing before we can go through with it. So we just did parabolas and hyperbolas before, but here you can see they're a little bit different. Both are squared like a hyperbola, but it's being added, right? So not a hyperbola, it's not a parabola because they're both squared, so that means this is either ellipse or a circle. And the difference between those two is that the ellipse will usually have numbers underneath here and will be equal to 1. So if we have no numbers underneath the x or the y, and it's not equal to 1, we have a circle. Okay. As a circle. There we go. Okay. And we have a center of 0, 0. There's no pluses or minuses with the x and the y. And we have a radius of 6. 1, 2, 3, 4, 5, 6 in each direction. 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right? And just do our best to keep about the same distance away the whole time. There we go. And there we go. Okay. Number 26. Very similar, but you can see we have a 9 here in the front. That's a clue that this is not a circle. We don't have just x squared and y squared, but something else in addition. So I'm going to divide this by itself on both sides, and you're going to see this will take the form of an ellipse. All right, so 9 over 36 gives us, let's see here, gives us x squared over 4 plus y squared over 36 because the y didn't have anything to cancel it out, and now it's equal to 1. So we can see looks very similar to a circle to start off with, but because of this one number, we need to go through and make it into the ellipse format equal to 1. So we're going to have a center of 0, 0 once again, right? But the left and right axes will be 2 to the right and 2 to the left, right? Square root of 4 is 2. And then we have the vertical here of 36, so we're going to go 6 up and 6 down. And there's the ellipse. There we go. Very good. Let's go to 27. We have, once again, 2 squares, but a subtraction, right? So much like those problems up before, you can probably tell that this will be a hyperbola because of the subtraction. Right, so hyperbola is just like ellipses, got to get it equal to 1. So I'm going to divide this by itself, right? Whatever number's on the right-hand side, divide by that. So we'll have x squared minus 36 minus y squared over 36 equals positive 1. All right, now since the x squared is the positive, it's good to know this ahead of time. We know it's going to open left and right. And that's very important to know before we start. If the y was first and it was y squared minus x squared, then it'd be opening up and down. So we're going to start at 0, 0. All right, and it's going to be going 6 in every direction. So we'll be going 6 this direction, 6 this direction, right, up and down. There we go. And then I just follow these until they meet. So I'm going to use different color. I'm going to use these guiding points right here, these corners. So you might remember that we drew some of these boxes like this to help us graph. And they meet at these corners. And with these corners, we can draw these guiding lines. So you're going to draw a these lines that go through the box at the corners, right? And that gives us some guidance for the hyperbola. So with this being drawn, I know here are going to be the focal points, but I use these other diagonals I just drew to help me guide where the graph should go. It gets close to, but never actually touches these diagonal lines. And we do the same thing on both sides. So it's a little different as far as graphing. We have to do a little bit more setup before we can draw these in if we're going to be accurate. So there we go. So it looks like these would keep on going, but never intersect with these diagonals if we kept on going on forever. There we go. Let's see here. Lastly, do 28. You can see that there is only one square here, which means it's going to be a parabola. So a lot of these look very similar, but one slight difference, like not having a square. So let's get this in the proper format. We're going to have an x squared here. So my goal is, right, to have this. We're going to have a LOR with a y here. And on this side, we'll have an x squared. Okay, so this will be the general format. I know the x is going to be the square because I can see it here. The y does not have a square, so there's no square here at all. Right? It's just about manipulating and moving things around so it gets into this format. So let's see here. We want to have the x's on the right-hand side, like here. It's on the left side here. So let's start by moving that over. So now we have 4y equals x squared plus 36. Right? And we only want the x's here. So in the same manner, we're going to move this 36 to the other side. So step one is get everything onto the correct side. So now it's looking a little bit better. So now we want to create this parenthesis here for the y variable, right? So I can do that by getting the LR out, by factoring this out. And you can see both of these divide by 4 evenly, so that makes it easy to work with. So if I factor the 4 out, now I know my LR, and what's left inside is the y and minus 9, right? And on the right-hand side, we just have x, and there's no number here, so I'm not going to have a plus or a minus, so it's kind of like an x plus 0. We don't need a right plus 0, but that's just that it's not going to move left or right. So we're only going to move, looks like down or up 9. That's going to move up 9 here. Okay. And let's see here. Our LR is 4, so that means we're going to go up 1, and it's going to be 4 crossed right here. So this is actually right at the very top of this graph. Very, very top. Looking like that. All right, so here we go. All right, let's go to 29. And we need to determine the conic section, what it is first, right? And then graph it, and then label everything that we need to. All right. So when you're determining the conic section, often, let's see if I can get this. And there you go. Often, we just need to look at these two parts. So there's a lot of stuff here, but you want to block that out and just really look at this and see, well, they're both squared, so we know it's not a parabola. It's positive between them, so it's going to not be a hyperbola. So we're down to ellipse or a circle, and you can see there's no coefficients in front of x or y. Kind of like the last problem that had like a 9 in front of one of them. that made an ellipse, this does not have anything in front. Or if they're the same value, that would keep it a circle. So we're going to have a circle here. So we need to work with the whole equation, but at first, just determining what type of conic section it is, look at just the squares for the x and y, and you can tell, let's make that smaller now, you can tell what type of conic section it is there. And the next part is really to group the x's and the y's together. So I have x squared and 6x, so I'm going to write those together. I'm going to leave a little space to complete the square. And then I have my y squared minus 10y. Leave a little room to complete the square. And then lastly, I am going to move this constant term to the other side. So I'll have negative 25 on the right-hand side. So this is a good way to set everything up. Okay, and I'm going to, below here, write my circle format. Get everything ready. So first, to complete this square, I'm going to have x, and then divide this by 2. It gives us 3. Square this, 3 squared is 9. So I'll have to add 9 here and 9 on this side as well. And then repeat the process with y. I have negative 10, so I'm going to have y minus 5. 5 squared is 25, so I'm going to add 25 to both sides here. And then that will give us an answer of 9 on the right. The two 25s, the negative and the positive, cancel out. So there's my equation of a circle. So I got a center of, the center will be at negative 3, positive 5, and the radius will be 3. Okay, center is negative 3, positive 5, right up here, and we'll go 3 in each direction. 3, 3, 3, and 3, and just draw the best circle you can, like that. There we go. There's our circle. Right, let's look at the next. Let's see here. We have, once again, ignore all this. Okay, we're not going to use that at all to identify what we're graphing first. So we have both squared. One of them is negative, so that's a giveaway that this is hyperbola. Both are squared, one of the squares are actually negative. Okay, so we have to know, okay, hyperbola. And you'll notice even more that the y is a variable that's positive. So this is going to be an up-down, opening up-down hyperbola. And we'll do the same process we did with a circle, group the x's together and then the y's together. Okay. So actually, usually we write the positive first with hyperbola, so I'm going to put the y's first because that's positive. So I'm going to have 4y squared minus 8y, leave a little space. Then we'll have the minus 9x squared minus 18x, leave a little space to complete the square. And then on the right-hand side, I'm going to move the constant over this 41. So we'll have equals to 41. Now, something a little different here is that we have coefficients in front. So we actually need to factor these coefficients out first. So you can see a 4 goes into both of them. So I'm going to take that out first. So I'll have y squared minus 2y, still leaving a space, and then minus 9 is going to come out of both of these. So I'll have x squared, and this will be plus 2x, leave a space. That equals 41. And notice how this is positive because I took out the negative as well as the number. So if you want to double check, you can make sure that these should multiply back to whatever's above it, and negative 9 times 2 does multiply back to negative 18. So I know I'm okay here. And now, with this little extra step because of hyperbola, I took out these two GCFs. Now it's the same as the ellipse or circle. You just need to complete the square. Okay, so here we go. We'll have that 4 in front. We'll have y, half of negative 2 is negative 1. So I'm going to add 1 to both sides, or 1 into here. Now, actually, I'm not adding 1 to the left-hand side, even though I put a 1 here. Because there's this 4 on the outside, you'll notice that I'm going to add 4, right? Not just 1, but 4, because I'm really adding 4 times whatever this is. Okay, and that's going to be squared. Same thing here. We'll have x plus, and then half of 2 is 1. 1 squared is 1. But I need to do 9 times 1. So I have a squared, negative 9 times 1. So on this side, right, we have it negative 9 times 1. We are going to have minus 9 because of that. There we go. And if we simplify this right-hand side, 41 plus 4 is 45. 45 minus 9 does give us 36. And lastly, let's just divide everything. Because it's hyperbola, we need this equal to 1. Divide everything by 36. So we will have 4 over 36. That'll give us a 9 on the bottom. So we'll have y minus 1 squared over 9 minus 9 goes into 36 4 times. So we'll have x plus 1 squared, and this will be equal to 1. Okay. Now we just need to graph. So we have a center at negative 1. See, we have negative 1 here, so that's going to be positive 1 for y, and positive 1 for x. So x is be negative 1, y will be positive 1. So we'll start at center of negative 1, positive 1. And in the x direction, we have a 4. So that means we're going to go 2 to the right and 2 to the left. The y direction, we have a 9. So we're going to go 3 up and 3 down. All right. Create this box here to give us some guidelines for our diagonals. So we'll be going this way here, and then this way here. There we go. And already mentioned that since the y is what's positive here, right? This is the positive variable. This is a negative x. So we're going to go in the y direction for the graph, up and down. Use these diagonals to help guide our graph. Get close to, but never actually touch those diagonals. There we go. And there is our graph. All right, let's go to our next problem here on number 31. So we're just going to continue what we're doing. We see we have to figure out what we're graphing first. So once again, let's ignore this part, right? And just focus on the squares. So we have an addition, right? We have both of them squared. So we know both are squared, not a parabola. It's an addition, not a hyperbola. And the last two would be circle or ellipse. And the fact that these are different coefficients lets us know that this must be an ellipse. Right? If they're the same coefficient, or if there's only a coefficient of 1, then we'd have a circle. So we definitely have an ellipse. And we can go through the same process we have for the others. Let's get the x's together. All right, leave a space to complete the square. Get the y's together. So we have plus 16y squared and plus 96y. And leave a space to complete the square. And it's going to be equal to negative 81. All right. So like the hyperbola, we need to factor out a GCF. In order to complete the square, we need this square to actually be a 1 here. That's why we're taking this out. So we're going to have 6 plus whatever number completes the square, parentheses here, and then take out the 16 from the y squared. So we'll have y squared, and then 96 divided by 16. Let's see what that is. Get my calculator here. 96 divided by 16. We'll have 6. Okay. Right, and this still equals negative 81. All right, now let's set up to complete the square. So we have parts that are not going to change here, so I can get that in first. Okay. And then we're going to take half of 6, that's 3, square it. 3 squared is 9. And then on the right-hand side, I need to add this times this, right? That'll give us 81. So that's essentially just going to cancel out the negative 81 over here. So ellipses and hyperbolas, we have to do this. Circles, we do not. And same idea here. We'll have 16. And we'll have y plus half of 6 is 3. 3 squared is 9. And we'll have to do 16 times 9 and put that on the right-hand side. So 16 times 9. We have 144. So we're going to add 144. So on the right-hand side, this will equal 144 because the 81 and negative 81 just cancel out. And we can divide both sides by whatever this right-hand value is to get it equal to 1. There we go. And then we just have to see, well, how many times does 9 go into 144? So nice to have a calculator on this problem right here. So we have 9 divided by 144. Well, that gives the decimal. So let's actually do 144 divided by 9. So we'll have a 16 down here on the bottom. And same thing here, we can do 144 divided by 16. And then we have a 9. So we'll have a 9 down here. So we have x plus 3 squared over 16 plus y plus 3 squared over 9. That equals positive 1. So we have an ellipse that looks like it's wider than it is tall, right? 16, so that's 4 across, but only 3 up and down. Starting at negative 3, negative 3. So negative 3 comma negative 3 is right here. And we'll go 4 to the left, 1, 2, 3, 4. 4 to the right, 1, 2, 3, 4. 3 up and 3 down. There is our graph. So we got our center, our major axis, and our minor axis. Remember, the major is just the longer, and the minor is the shorter. All right, last one. Okay. Here we're going to have, looks like a parabola. Okay, how can you tell it's a parabola? You look for the squares, and you can see there's only one, a y squared. So not only is it a parabola, since it's a, let's see here, spell this right. Since it's a negative y squared means opens left and right, negative y, that possibly could be left or right. It depends on how it works out. Okay, so, but we definitely know left or right. So let's see here. Let's get the format we're going to need. We need the LR. We're going to have x possibly plus or minus something. And then the right-hand side, we are going to have y and something squared. So this is the format we're going for. So I want to get the y's, two y values right here and right here, onto the right-hand side. So let's do that first. So that'll leave me with 8x will be left on the left, and this minus 12 will be left on the here. And then on the right-hand side, we'll have positive y squared when I add y squared to both sides. So it's positive y squared. And then I'm going to subtract 4y both sides. So I'll get minus 4y. Now, like the other conic sections, we need to write this as something squared. So I'm going to complete the square, just like we did before. So I can have, right, something squared. So I'm really doing this, and I have to add the same thing to both sides. So y, half of negative 4 is negative 2, and then negative 2 squared is 4. So I'm going to add 4 to both sides here. And that'll leave me with a square on the right-hand side. And on the left-hand side, I'll have 8x and now minus 8 from 4 minus 12 gives us minus 8. And remember, we want to have that LLR here on the left-hand side outside the parentheses, so we are going to factor out this 8. So I'll have LLR of 8 left with x minus 1 on the inside, and then we'll have the y minus 2 squared on the right-hand side. So it looks like the center, well, not center, it's a parabola, so instead of a center, we have a vertex. The vertex is going to be x of 1, y of 2. LOR, that helps us graph, is going to be 8. And our p-value is going to be, see, remember, LOR is the same as 4p. So if LOR is 8, 4 times p is 8. So if you just solve this, p will be 8 divided by 4, which is 2. So we can go ahead and graph this here. We'll have 1 comma 2, start here. We're going to go, looks like an to the right, a value of 2, right? And then we're going to go LOR of 8, so that means I need to go 4 up and 4 down. 1, 2, 3, 4. And that will give me my graph. There we go. Opening to the right, because we have a positive LR here, so I know it opens right. Since it's Y, it has to be right or left.